So today in class we did some polar graphing. We're still trying to get our heads wrapped around this whole polar coordinates thing. And so in our groups we worked on graphing the graph r equals 1 minus sine theta. And so for this, theta is acting like our input and r is acting like our output. So when I look at this, I see that they're giving me some thetas that they probably want me to plug in. So I'm going to start with 0. Okay. And since I'm going to graph this and I'm just going to use decimals to graph, I'm going to go use my calculator. Now, I'm going to make sure that my mode is in radians right now because I notice that these are pi over 6 and pi over 4, and I know that those are radians. So I'm going to do 1 minus the sine of 0, and I get 1. And then I'm going to do 1 minus the sine. Let's see, the next one is pi over 6. And I get 0.5. Okay. And then I'm going to do 1 minus the sine of, let's see, the next one is pi over 4. And I get about 0.29. Okay. And I'm going to continue filling this out. I'm going to go ahead and pause for a second while I finish filling out the rest of this XY table, or theta r table. Okay, so the magic of video recording is I just skipped ahead and filled out the rest of this table for the values going around the circle. And now I'm going to graph these. So 0, 1, I'm going to go 0 degrees, or 0 radians, sorry, and a radius of 1. And I'm going to come out and put a point. And then I'm going to go up to pi over 6, and now my radius is 0.5. So this is 0.2, 4, 6, 8, and this is 1. So let's see, 2, 4, there's 0.5. Put a point. Then I'm going to go to pi over 4 and go 0.29. So let's see, 0.2, 0.4, somewhere in the middle there. And then pi over 3 is 0.13, so inside of 0.2. Okay. And then pi over 2 is 0. Okay. And then if you notice, my values start repeating. I have some symmetry here because sine is symmetric on either side of quadrant 1 and quadrant 2. And so my points are going to be symmetric as I go back out. So let's see, 5 pi over 6 is a half. Okay, and then I hit 1 again at pi. Now I know it's labeled -1 here, but remember -1 is just to tell you that it's the opposite direction. And really this is still the circle of radius 1. And then I'm going to keep going around. Now I'm at 1.5, so let's see, 1.2, 4, there's a half. And 5 pi over 4, I'm going to go at 1.7, so let's see, there's radius 1. 1.2, 4, 6, 7 is going to be in the middle there a little bit. And then 4 pi over 3, I'm going out to almost 1.9. So here's radius 1, 2, 4, 6, there's 8. I'm going almost all the way out to 9. Okay. And when I come around to 3 pi over 2, I'm at 2. So I'm down here like this. And then I'm going to have symmetry, if you notice, as I'm coming around my curve. And so I can go ahead and just graph these points using symmetry. So let's see, that's coming around on this circle. It's kind of funky doing it on a circle, huh? Like that. And then I can connect my points. Now this is called a cardioid, or if you notice at the top, cardioids. And if you look at the root word cardio, you think of hearts, like your heart rate, like if you're going to go out and do some cardio. Okay, so this is sort of heart-shaped, kind of more tomato-shaped, but that's okay. We'll take it. The next question asks us when or at what points will the tangent to this curve be vertical? Now, if you guys remember, tangents to curves are lines that touch just once and never again. And so what it's wanting you to do is think of when a tangent to this curve will be vertical and figure out what that point is. So one of the tangent lines looks like it's happening right here, and I would say that that point is at 7 pi over 6, and at 7 pi over 6 we are at 1.5. So that would be one point that would be tangent line would be vertical. Can you find another one on this graph where the tangent line would be vertical? And then the second part of that was when the tangent line would be horizontal. And so then I want you guys to look and try and figure out when would a curve that's tangent to this graph be totally horizontal. You're going to be looking for points where the tangent line is horizontal. There's probably going to be more than one. All right, good luck, and I will see you tomorrow.